Hi, welcome to Tech Ranch, a place where we learn and earn technical skills in the most efficient way. Let's make coding fun. Algorithm and implementation, Radix sort. Today we are going to present you a live demonstration and implementation of Radix sorting algorithm in Java. Before we get into the demonstration, let's first see what is actually Radix sorting. Radix means the base of a number system. For example, you have number from 0 to 9, that is the base of 10. Based on these digits, we try to sort numbers is basically the fundamental of Radix sorting algorithm. Few more important facts about the Radix sorting. This type of sorting algorithm is a non-comparative sorting algorithm. We have seen a few other kinds of sorting algorithm which are comparative. Like we pick two numbers, we compare, and then we placed it and provides a position. In this case, in Radix type of sorting algorithm, we create a small bucket kind of thing or a kind of a pot where we place and we keep the numbers and distributed based on their radix. That's what the non-comparative sorting algorithm. So it avoids a comparison by creating and distributing elements in buckets according to their radix. To do digit by digit sort, starting from least significant digit to most significant digit, it uses counting sort as a subroutine to sort. A list of integer numbers will be sorted based on the digits of individual numbers, and sorting is performed from least significant digit to the most significant digit. That means like it is in an ascending order. So we are placing the numbers based on the least significant digit to the most significant digit. For example, if the largest number is 3-digit number, then that list is sorted with 3 passes. Now, what does this mean? Since it is placing the numbers in the digit wise, so the largest digit number you have will take that passes, will take that buckets to place it. That will be more clear when we see the live implementation and demonstration. Let's first see the example. You have numbers like this. As you can see, it is a combination of different types of numbers with different number of digits. 1, 23, 45 and 788. So here we have ones, tens and hundreds base number. So based on that, if you see the radix of these numbers, the 1 is the radix 10, 23 is for the tens, then hundreds. So based on those radix, based on those digits, we compare and put it in a bucket. We just pick the number and put it in the radix based bucket. For example, we pick the 121. So 121, if you divide this into 100, then it will be 0.1. So your last digit will be 1. Now this will be placed in the bucket which has a radix of 1. Similarly, for if you see the 1, this is also comes in that bucket. Now since it is 100 and it has 3 digits, it will pass that loop and iterate it 3 times automatically. So we will have the implementation and see the more in detail. Now let's take a look at the flow chart. It will start and then we'll count, and we have the I start loop, and that I will check with the radix, the base. So that is what the greater than equals to 10, and if it is yes, then it will make a sum, another variable, and initialize with 1, j, another loop, and that again it will keep iterating that loop and put it in a bucket based on that. So this is what the flow chart, and in case of no, then it will stop and go back to the start position and exit from the loop. Now let's take a look at the algorithm. It contains 3 major steps to perform, and that particular it in an iterative form. So first step, we create an array of n elements and call count sort repeatedly on least to most significant digit of each element as the key, and then the last step, we return the sorted array. So that particular step 2 and step 3 is in a repeatedly iterative form until it will have the most significant digit identified. So this is what the algorithm. Now let's take a look at the implementation. So as we have seen, the radix sort based on the radix, the base form. So we need to calculate the exponential, and that exponential will be check which one is the biggest number, and then we'll put it in the counted sort bucket kind of thing, or kind of a buffer you can say. So here we'll create another array for it, and then we'll keep it safe there. So as you can see, we have created one method called GetMax to find out and identify the maximum greatest number in the array. For that, all we need to check for the digit, and we'll find out the digit, and that digit will be placed in that bucket. Count sort will be the one where we are going to calculate the base of it, and then we'll place it into the array. And the radix sort will be the method where we call this max method and the sort method, count sort method. As you can see, the GetMax will have the array and the size, and the count sort method has the argument of your array and an exponential, the base, the radix. Print will display the entire sorted and unsorted list. Now, for example, in the main, we call the radix sort method and the print method. It is a static method, so you don't have to create a complete class, objects and everything. You can just make a call of it in the simple form. Now, demonstration, we'll see the execution will be like this. We have the sorted array, and we have the unsorted array, and we are going to print it the sorted one, and make sure you have the list of numbers in a different radixes. That means, like, for example, you have the 2, 24 and 170. You can have the thousands number too. So 3 digits number, 4 digits number, and mixed it up, and then we'll see the how it works. So all you have to remember is, like, the larger number of digits in a number exists in the list, that number times the iterative that loop will pass. So let's see the demo. And so this is my Eclipse IDE, and I'm just going to create, so this is my Eclipse IDE, and I'm just going to continue with my sorting algorithm practice project. And inside this package, I'm going to create a class is Radix sort algorithm demo underscore tr, and I need a main method, of course, and finish. So this will have the complete package and your sorting algorithm. Inside this class, first thing first, we need to have the static GetMax method. So which is in a static return type integer, because it's going to return the maximum value of the number in the array. And creating an array, and we need to pass the argument of number, the size of the array, what it exists, because based on that number, let's make it max equals, suppose we just have one maximum variable which is assigned to first digit. We'll first pick one number, and we start putting it and place it in a proper position or a proper bucket of the number. So for that, we need to calculate the base, and that can be done. What we need to do, we need to have a condition, if condition, where array of this position, the one which we picked from the loop, is going to compare it with max number, what we have chosen from the first number. So picking the number and then check if it is a greater and what kind of base it has, and based on that we'll assign it. Return, if it is true, then you have to return max. It's max. static void count sort method int array and the size and the exponential. Since exponential, that's what the base is all about. Now int output array, the array which is going to be sorted form, and initializing of array with your size n, termination, and this array will be like your output array. Int count, and this count will exist your count sort kind of thing, where we are going to implement the simple counting array, which is another kind of algorithm, a simple algorithm, where sorting algorithm, where it is also non-comparative. We'll see in the next session if you're interested to know, learn about it. For loop, here we have I, another kind of loop we need to put, because we need to have the exponential base and array size, so we need to read the entire array. So for that, first we need to count, and that array has the array exponential I. It will read per loop and exponential the base, which is going to be calculated with the help of your percentage 10, and it will be increment by that. So what is happening here, we forgot to put the bracket here. So this will have the counted array, which is creating a kind of a bucket, where we'll keep a safe of those elements which is existing on that Radix, the base. So it is called as non-comparative because we are not using any kind of pivot theory. Here we are using the bucket theory, where we have some buffer kind of thing which is safe for those numbers which exist, and organize it in a Radix basis form. That's the concept behind Radix sorting. For I equals to n, that will for the reading back, you see, because one we have compared and iterated. Now for next number we need to read the another number. For that we need to just have a loop for decreasing it. Output array, the one which we are using to store our output array, then counted bucket, and inside the counted bucket we have array which is reading again from the exponential. So it is again calculating your base and assigning that value to the output array, you see. So it will iterate it until it will find the least and the most, from least to most digit number. And then we have the count array. Again this will be the array where we are reading it, our exponential percentage to calculate the base. So it has to pass until the most significant digit you can find, and that number time of count sort will be called. And the next since it is decreasing back, it has to get closed. Now what is this output here? I think I renamed it with some other variable. It must be out. Yeah, see, I just named it out, just general out. Now count sort is done. Next method we need to have the radix sort, where we are going to place it. So for radix sort, let's have the static void radix sort method with arguments of array, the one we are using it, and the size of the array, so that number type of the loop will iterate. Int assume your max. I don't think so it will work because we have already used that variable get max method and array and n, right? So this will have the method, this method will help to get the entire process again. For int exponential equals 1, we cannot reuse the same variable, so I'm just using the another variable, and exp. This logic will help you to get the count sort. Calling the count sort, you see, we need to call the method and put it in a radix sort. So count sort will have your array, n type of numbers, and exponential. So this is your count sort and radix sort. And last, we need to have the display method. Static void display method, which has your array and your size of the array. And we'll see the arrays, and in it's just simple, where we are calling the loop and reading the array and displaying it. And assuming we have an array of size this one, and now as you can see, we have some errors here. Rename array. Okay. We'll see that later. First, let's finish with the main method. We'll have array method here. Array definition. Give some numbers. Let's give some numbers of 1, 25 and 34, 2, 56, 789, 875 or 6, 453, 32, 11, 6, 7, 8, 98, 5, 20, 100, or 1, 2, 1, 2. So this will be more than enough because that will take the number of size. So in this kind of array, what is happening? It will pass till 4 times. The iteration will work for 4 times because it has 4 number of digits in the maximum number. It has thousands of radix, right? 10 base of 10 and base of 100 and base of 1000, and that's how we have the base. That many type of your radix. So it's just for labeling radix demo. And First, let's print our unsorted list. So display array n. I think we need to include the entire class. That's why it's creating this array. Either we create an object or we can create an instance within the main method. So it will be all clean /n sorted array printing sorted list. So you see, display array. So after calling the Radix sort, the array is now in a sorted list. So we can simply print and display array. Now once this is done, this is just for labeling. Now let's take a look at the errors. We forgot to assign the output array to array, reassign it. Now you can see, now if I will have few more big numbers like 1, 0, 0 and try to execute. So here you can see it is the sorted one. So what is happening? We have the bases of the individual numbers and we put it in a bucket and then we keep iterating until it is sorted in the bucket based on the Radix. And this is how it's implemented in Java about Radix sorting algorithm. So we have seen the demonstration of implementation. Important facts. Radix means base of number system. So it can be 10, 100, 1000, 10,000 and so on. Least or most significant digit Radix sorting. So Radix sorting basically based on the Radix of numbers on a list, and since we are doing it in the ascending order, it will be from least to most significant digit Radix sorting. Radix sort is generalization of counting sort or bucket sort. Since it's not a comparative sorting algorithm, so it is in a kind of a bucket sort where we keep it in a buffer and then we sort it and place it in a proper position. It uses of several passes of counting sort. So we have seen the number of digits, the number of passes for individual bucket to sort the numbers. Radix sort is stable and fast, since if we have large number of digits or data and that will need to be sorted fast and stable, then we'll go with the Radix sort. Worst and average complexity are same, n multiplied by k by d. That means n is the number of numbers in a list, k is the probability, and d is the number of passes we need to have it. Space complexity is n plus 2 per d. So on the same base, if you have the best case or it have some other probability, based on that the complexity will differ. So this is all about the Radix sort demonstration and implementation in Java. We are going to have some more interesting informative sessions coming up soon. Please stay tuned, and for any kind of questions and source code or assistance needed, please contact techranch2019@gmail.com. Let's make coding fun. Thank you.